First, the middle 5 sections were the original switchboard that was put into this facility when it went online in 1895. It's constructed of Tennessee marble for insulating purposes. The center panel here is where all the generators are brought together and the switches go to 2 bus bars, 2 3-phase bus bars on the rear of the switchboard, 3 and 3 in the center here. They pick up generator 1, generator 2, generator 3, and generator 4. Each have their own individual panel for operation. So when they get them onto the bus bars in the back here, they're taken upstairs where they go to the transformers. Originally, they had transformers upstairs. Those transformers were air-cooled, and there was 250 watts each. The 12 transformers upstairs transmitted 2 3-phase 11,000 volt circuits into Sacramento, a distance of 23 miles. Those Thompson meters are unique in that they're taking the full 1,200 amp load of each bus bar. These switches here, this is for the upper bus, 3-phase bus on the back, and we had another 3-phase down here. These 3 switches were for the lower bus down there on the bottom of the switchboard. End of the switchboard were added subsequent to the opening of the panel. They represent switching and metering of additional facilities that were put in here after it was originally opened, such as the transformers out front, which are 860,000 and 100,000 volt transformers, and the lower powerhouse below here, which was 11,000 volts. That was just monitoring and metering. After the first year of operation, they determined the American River doesn't run natural flow year after year. They were short of water and they had to cut down on some of the, one of the machines in order to keep operating throughout the year. So they decided in 1897 to build a second powerhouse, reuse the water in the after bay, and this second powerhouse had 1 generator in it. The generator had to be above waterline. The turbine was above high water line of the river. So they used a rope drive between the turbine down here and the generator here. Initially, number 4 generator was moved down there so they could keep at least 3 generators in this plant operating. And number 4 was moved down there. This generator was turning at 300 RPM. The drive on the turbine was turning at 150, so they had a 2-to-1 ratio between the turbine down below. This is the turbine down below, and up here. This rope was tensioned, made 25 passes around the upper one and the lower one, or the upper spindle there. And it was tensioned at the upper end of the powerhouse here, this tensioner. It was replaced in 1900, and a new generator was put in down here. In this photo, we'll show you that the field current is now on the rotor, and the AC current operating facility is in the stator, so that they could generate 11,000 volts directly here without having to be transformed up from 800. That was a modification in the 5 years' time between the building of this plant and 1900. This is also a General Electric. Okay, let's start with the turbine down below. It sets below high water mark of the river. And it was brought in through a pair of gates we'll look at later on the outside. But those gates would be open, the water was flowing here. This was a low-speed turbine at 150 RPM, had big flywheel down below, turning at 150, and there was 2,300 foot of continuous rope between the generator flywheel here and the one down below. And that was the drive system for this generator. If you look on the back wall, you probably can't see it, but there's flood levels up there that show that this turbine was underwater. And of course, I don't think the thing was running when water was in there. You will notice that the fuel coils are on the rotor here, and the small cables that are coming out, that's because the current is very limited. It may be 20 amps to feed those fuel coils. It's turning at 300 RPM, and on the outside, behind this shield here, you'll see the AC coils, three-phase AC coils, and that's generating power at 11,000 volts. Doesn't have to be transformed up to ship it down to Sacramento. It's a switch for the whole system. There's three-phase switch.